In this video, I'm going to show you how you can use the Harmony 3 plugin of the MPLab X IDE to generate code that simplifies the use of GPIO pins. I'm going to assume that you know how GPIO works, but if you want more information about that, click the link above to get my video on GPIO. I'll start with simple input and output ports, and follow that with input ports for which we want to interrupt on a change of state. To start, let's talk about what Harmony 3 is. It's a plugin for the MPLab X IDE, whose goal is to generate code for the PIC based on how you want your PIC configured. In the past, MPLab had a code configurator and Harmony, but they've been combined in Harmony 3. This plugin will give us a GUI where we can describe how we want the hardware to be configured, and it'll generate a layer of code that will go between your code and the hardware. So this allows the code that we write to be at a higher level of abstraction, and therefore it's a bit more intuitive to develop and to read. Harmony is a plugin within the MPLab X IDE. When you add it, it'll ask you where to install the Harmony framework. Remember where you put it. In order to use Harmony, you want to create a new project that is an MPLab Harmony 3 project. This is where the plugin downloaded its framework to. Now their wording of location, folder, and name are a little confusing, so I like their visual help. The location is the root folder where the whole project will be, and you can share that among multiple projects if they share stuff. The folder is the folder inside that where your code will go. And then the name is the logical name that'll show up when you open it in CLine. So when I do this, this is where my root folder would be, and then I like the folder and the name to be the same, because then I don't have to think about it too hard. Then it will ask you to pick the processor that you're going to use, and so I'm going to pick the one that I'm currently playing with, the 370L. And when you finish with that, here's our project. There is a source folder, and that's where our C files will go, and a header file, that's where our H files will go. Once we have our project, we can get into Harmony by clicking this MCC button, which is really from the code configurator, but in Harmony 3, where they're put together, that gets us to Harmony. And some of these things take a while. I pick MPLab Harmony, and I don't need any other content right now, so I'm just going to click Finish. And I will warn you that some of these steps take a long time the first time you do it because it downloads a lot of stuff. When I do it at home, it could take maybe 5 minutes to do those steps. It starts with these two pieces, and we're not going to use these two pieces right now. They describe, if you click on them, they describe things that you can play with. But we're going to do, because we are configuring the GPIO port, I'm going to do pin configuration. And here it shows all of the pins on the device. And right now they're all available. Nothing has been configured at all. But let's say that RB2 was an LED. So it is an output GPIO pin, output GPIO pin, and then I can name it whatever I want to name it. So I say that is my LED number 1. I don't need to worry about these other things. It could be digital or analog, because I could drive it with VDD, it doesn't matter. Because it is output, I don't want to enable change notification, and there's not a pull up or pull down on it, so I'm going to leave it just like that. So the magic of Harmony is you set up your pins like this, and then I can click on the generate button, And it thinks for a minute. Now, if I look in my project, it has given me a main that initializes and then has a standard loop. These two, sysinitialize and systasks, are defined in definitions.h. If we look up here in the header files, definitions.h, right now, it has sysinitialize. Sysinitialize is actually defined in initialization.c that they also gave to us. And if we scroll down, it's doing a lot of things. It starts out by disabling the interrupts, sets up the clock, sets up some other stuff. The important thing is you can see it calls GPIO initialize. It also gives us, in the peripheral area under GPIO, we now have a plib GPIO.c that has an initialize, and you can see here it is setting up that one bit, the one pin in lat B, port B. And then it's given me a bunch of things that would let me read a particular port, write a particular port, yada, yada, yada. We're not actually going to use those because in the H file for that, it gives us really nice. Here is a define that lets us set, clear, toggle, whatever, that one pin. So as an example, in my main, if I wanted to turn the LED on, it was LED 1. That's all it takes to turn it on. So you can see what it's done is it's given us a layer of code that is above the hardware and below our code so that we can write our code at this higher level of abstraction. It's still important to understand that what that LED 1 set is doing is using the lat B set register and turning on the bit that is associated with pin number 1 in that register, which is the pin that we had played with here, RB2. Now we could also configure another pin to be an input pin. So let's say RA9 is a GPIO pin input. Why does it not do that the first time I click it? There we go. Say this is a switch. It's a switch, and it's a digital switch. And it's an input instead of an output. If I generate the code for that, and I go back and I look at my project, now I have things for the switch, and I have the setup for the switch for port A. More interestingly, if I go into that switch and I click that I want to change notification, and I generate the code, that means that I'm expecting that I want it to give me an interrupt on when the state of that device changes. Now, when I look at GPIO.h, I have the ability to enable and disable that interrupt. And when I look at my When I look at my PLab GPIO.c, I have the ability to set up a callback for that interrupt. So when my system comes up, I'm going to want to tell it for a particular pin, give it a function that it's supposed to call when that interrupt happens. So I have done that in another project. You can see here my callback function. Callback function has to return void. It has to have a pin as the first parameter and a context as the second parameter. And in this one, all I did was check to see if the pin that was reporting it is the pin that my switch is, which I got from my H file. Then I'm turning on a different LED or clearing a different LED. So that's what I want to happen when the interrupt occurs. And in order to tell the machine that that's what it should do on that interrupt, I call that callback register function that we saw in PLab GPIO.c. And the parameters to that callback register function are the pin that you want to attach it to, the name of the callback function that you've built, and in this case, I'm passing 0 as the context. And then I have to enable that interrupt. They all start not enabled. And so once you hook up the callback function, then you want to enable the interrupt. Bottom line, here are the steps that we use to get Harmony to control GPIO pins. If we do it correctly, Harmony generates a nice software layer that hides some of the details from us, and that lets us program solutions at a higher level of abstraction, focusing more on what we want to do, not so much how it gets done.